All right, good morning. We are at 99 participants. That's about the maximum we can take. So we're going to try to do something new today. This is the text message right here. We're going to try live instruction, problem solving using dimensional analysis. Some of you have skill in this area. A lot of you need instruction. That's why we're doing this session. Pear Deck is what we're using. So the recommendation here is that you have two devices, one where you're looking at the Zoom and one where you're doing the Pear Deck. You can do it on one device if you kind of switch back and forth between the two apps. And the things you will need to see through Zoom are when we say, here are some student responses, and you'll need to hear us through Zoom. You won't hear us through Pear Deck. All right, with that in mind, I think the right thing for me to do is to say this. If you do not need any help with problem solving with dimensional analysis, if you're a pro, then we don't want you here today, really. So if you want to delete yourself from our list, because we're getting above 100 and my maximum was 90. So you should be here if you want instruction, if you're going to participate. That's who should be here. Okay, with that in mind, the way we're going to do this is try to separate into three groups. We have three teachers. So each teacher will lead a Pear Deck session. So we'll divide into breakout rooms. You'll need to look at Zoom to figure out what's my code for the Pear Deck. Once you have the code, then each teacher will be looking to have about 30 students in his or her class. And we'll start the lesson that way. I am assuming you have familiarity with Pear Deck. If you don't, then try to communicate with your teacher or your peers who do have experience with Pear Deck. I find, I have no experience with Pear Deck. My first Pear Deck experience was this weekend. So I figured out how to use it as a teacher. It seems intuitive to me. You all have different devices. Some are really easy to interact with Pear Deck when you have to draw, and some are going to be more difficult. Each teacher will need to decide when is it time to go forward. I think it's a good lesson. It'll go through numerous examples and give you numerous opportunities to give your thoughts. What do you think? And if you do that well, we as teachers will understand where the weaknesses are. We'll know how to teach you better. Later on today, lesson 11 should be published. So you'll look for that in your Google Drive. Due date will be Wednesday. Our intention as teachers is that Wednesday, you'll be able to work collaboratively on that lesson. We did this last week and people liked it. It was successful. People learned. So instead of saying you work all by yourself in your little room at home, let's work together in our virtual rooms in Zoom. That's what happens Wednesday. So the due date is Wednesday night. If you come to Wednesday's Zoom, then you should be in really good shape. It shouldn't be, I'm guessing. It should be, I know exactly what I'm doing. I know why I'm doing it. That's how we're doing the instruction. Okay, with that in mind, we are now at 84. That's perfect. I'm going to make 3 breakout rooms. And, so the co-hosts, I'm going to do it randomly. And the co-host, I'm going to have to find them in the breakout rooms and say, maybe it'll by chance put one co-host in each room. That's what I hope it does. All right, let's try it. Breakout rooms. Making 3. Automatically segregate people into 3 rooms. Boom, 27 to 8 participants per room. I'm creating the rooms. I can get a brief glimpse to see where are my teachers. Where are my teachers? All right, Mrs. Perkins is in room 2. Ms. Holtz is in room 3. That means I'm in room 1. Here we go. Okay, I'm going to start the class at this time. So I'm hoping that on Zoom you see lesson 11. I'm hoping on your Pear Deck you see lesson 11. At this point, they're going to say the same thing. So pay attention to your Pear Deck screen as we go to the first point of interaction. Okay, so here's the first point of interaction. You have an opportunity to type something about a question your classmates might have about dimensional analysis. So I'll be able to see your responses. I may highlight a few student responses, but my hope is that I'll see what you're thinking. All right, so I have responses coming in now. Great. Okay, so many of these questions are general, which is great. Some people are saying, where would I use this? How can it be applied to everyday life or specific things like aerospace? Why is it important? All right, for the, I think, so I have to judge on how much time to allow for responses. I think at this point I'm going to show you some responses, and yes, these are generally good, and these are, yeah. Okay, so why don't I just show you these 4 here. All right, so this is a sampling. This is not everybody's response, but it's a sampling, and many people have responses similar to this. All right, the idea of dimensional analysis. I will quote Jason Zide, who works in aerospace. He works for SpaceX, and he said, the most important thing I learned in high school chemistry was dimensional analysis. So he uses it to do the calculations that are needed to launch spacecraft. It helps him organize his thoughts. It's a really powerful tool if you learn it well. So it's not just used for science, though typically you learn it in science. These next 2 questions are more specific, saying, well, how do I know which numbers to put in and where do they go? And that's what today's lesson will be about. How do I know where to put the numbers and set it up properly? Okay, thank you for your responses. Going to go forward now to our first example. All right, here's an example where I'm asking you to draw a specifically circle. But the question is a typical dimensional analysis type question. If a household needs 108,000 kilojoules of energy each day, how much propane must be burned to provide that energy? So that should look to you like a typical question we've been doing in chemistry with energy and molecules. So I've given you 5 choices in different colors, and I'm asking you to try to circle which ones do you think are important. You can circle all 5 if you think all 5 are essential, but you might say, oh, it's not all 5, it's just this one, this one, this one. So go ahead and circle the ones you like, and I'll be able to see your responses, and maybe I'll try to share all the responses this time. Okay, so most people seem to be circling. The average number of circles is 3. Do we have consensus on the 3? Not really. Okay, I may be able to show all the responses this time. And yeah, most people have circled 3. Some people circled 4. Now more circles are going in. I'm going to lock the screens and I'll show you the responses. Okay, so there's a whole bunch of responses, and you can see most people circled 3, and there's not really any agreement on which 3. So that's a good place for us to start. Which numbers matter is probably the most difficult thing to do in dimensional analysis, to say which numbers do I use? What tools do I use? All right, in this case, I'm going to go. Ooh, what happens if I do that? There we go. I'm going back to the original question. I'm going to highlight the idea that the answer to what do you need depends on how you interpret this question. How much propane? Because that can be expressed in different ways. Maybe it's expressed in moles, maybe it's expressed in grams, maybe it's expressed in liters. This is a vague question, how much propane? Therefore, there are multiple ways of answering it. We'll go and see 3 different ways of answering this question. They require different tools. We can do them all with dimensional analysis. All right, let's go forward. Okay, here now, there's nothing for you to do on this slide, so you just listen to me. Look at the slide, listen to me. It says now, I changed the question. Now it's not how much propane, now it's how many moles of propane. That's a much more specific question. If you need 108,000 kilojoules of energy, how many moles of propane must be burned? And to answer this question, there's a picture of the fire. There's a picture of the fire, so that's supposed to help you understand. What are we talking about? We're talking about there's energy, heat coming out from burning the propane. How many moles? In this case, all we need is this. All we need is the balanced chemical equation. Don't need a periodic table. Don't need anything other than, can you read this? Because the chemical equation relates the number of molecules, that's what these 1 and 5 and 3 and 4, those coefficients tell you how many molecules. And that can also be expressed as how many moles. So try to clearly see the connection between moles and molecules. Moles. And the quantity of energy, I wrote it in red, so it looks to you like energy, I hope. It's kilojoules. So with this, we can answer the question above, just with the chemical equation. All right, here's your first chance to do some dimensional analysis. I'm asking you just to choose the correct setup. Don't try to answer the whole question. Just say, which of these setups, there's an orange one A, there's a purple one B, there's a green one C, which one looks right for answering the question? So choose the correct setup, please. I have responses coming in, albeit, to me, it comes in as a graph. It comes in as a graph. So I have 13 responses now. More numbers are coming in. Good. All right, perfect. Perfect. Some people are changing their mind, it looks like. Okay, I have 19 responses. Okay, that looks like all I'm going to get. Okay, so once again, I'll lock your screen. And now I need you to look at the Zoom to see, what did people think? Survey says most people chose B, purple, which is a good sign because B, purple is the correct choice. But now we want to say, why is that correct? And so let's go back and see the, oh, okay, there we go. Okay, so B is the correct response, the purple one. The reason being the kilojoules here will cancel. Kilojoules cancel. When you choose the correct setup, then something has to cancel. Here I've got kilojoules and I've got grams on the bottom. Nothing's going to cancel in A, and nothing's going to cancel in C. I have kilojoules, but they're in the wrong place. Okay, so that's the idea there. Now let's go to the next slide. So here, you can see on the Zoom screen, I guess on your Pear Deck screen also, that the kilojoules cancel, and therefore we're ready to do the calculation to get the moles. So please try to calculate your answer now. In this case, students will submit a number, and once again, for me, it comes up as a graph. For you, it won't come up as a graph. But try to use a calculator or your phone calculator or your Chromebook calculator to get an answer to this question. I have 7 responses, 9, 10, 11, 12, 13, 14. Okay, kind of like popcorn, they're coming in. If you're not sure what to do, I will tell you in a few seconds after I've gotten many responses. Looks like most people do have the correct response, which is a good sign again. A good sign. Okay, looks like I'll lock the screen now. And, well, a few more seconds. No, I'll lock the screen now. Okay, I'm locking the screen, so now pay attention to the Zoom. So there are only 2 obvious places people respond. It's not a continuum. So there's this 49, and there's about 250. So if you do the math correctly, the answer is 49. So let me show you why that's the correct answer. So when you have dimensional analysis and you've set it up correctly, the math you do on the calculator is multiply by the number on the top and divide by the number on the bottom. So this should be on the calculator 108,000 divided by 2200. And that's how you get the answer of 49. Okay, so that's what it would look like if you were doing it perfectly. The kilojoules cancel. The mathematics is 108,000 divided by 2200. It's not 49.000, but we round and say 49. Good enough. That's the answer to the question. All right. I should have put a slide. Ooh, let's see if I can put a slide. I don't want any of these silly things. Okay, maybe that's not what I want to do. Because I should have put a slide saying, tell me if you have any question at this point. So at this point, the best I can do for that would be, you can always put questions in the Zoom chat, though that's not ideal. Okay, I'm going to go forward, hoping that people are understanding. The data so far suggests so. Okay, so we're on this slide. Now we're going to this slide. All right, we answered the question. We answered the first question. Let me go back. We answered this question. How many moles of propane? 49 moles of propane. So we've got an answer, but maybe it's not the answer that's really useful to you. And that's what dimensional analysis is good for, is say, I will put it in a way that is useful to both me and others I am working with. So let's try that. Maybe moles is not so useful. Maybe grams is more useful. Can we turn the 49 moles of propane into grams of propane? So this is a drawing one. So you could draw anything you want. You can also, on the drawing slides, you can choose the text option. If you like to type it, that's fine, because there's a text option in the drawing tools. Okay, so I'm starting to get responses, and some people are showing an attempt at dimensional analysis, and some people are writing text. And okay, so people are doing a whole bunch of different things. So I think I'll show you all the answers, but I'll wait for people to finish putting something on their page. All right, I'm going to stop there. I know some of you aren't done, which is fine. That's kind of the point. It's fine to be undone. Okay, so I'm going to lock the screens there. I'm going to show you responses on Zoom. Okay, so look at the Zoom window, and you can see a wide variety of responses. And some of them have an answer, and most of them don't. And some of them clearly need some instruction, and that's why I'm here. All right, so that question is a valid, important question to be able to answer. So if I scroll here, I guess you see everything that I see. That's cool. Okay, you see everything I see. All right, let's go back to some instruction now. So this question here will require the periodic table. So you remember that early question, what do you need? Well, if you're going to do moles and grams, periodic table is your friend. So on the periodic table, there are these masses for the various elements. They're called atomic masses. And what you want is called a molar mass to convert moles to grams or grams to moles. So I'm asking you again on this slide to make a calculation. Try to figure out, based on what you see on the screen, there are 3 carbon atoms. I've shown you the part of the periodic table that's useful. Can you come up with the molar mass of C3H8? All right, so we have 5 responses already. Now we have 7. Now I have 8. 10. So in case you're wondering, which you probably aren't, but I'm looking at the responses on a second device. As I asked you to have 2 devices, I have 2 devices. So I am looking at my tablet here, and that's showing me all the answers. And what I'm projecting on my desktop is the Zoom screen. All right, beautiful. I have 14 responses out of 25 students who are, I don't know, it says 22/25. I don't know how many students I actually have. All right, but we're at 15 responses. All of them are correct. So I can go ahead and show responses, and you'll say, yes, everybody guessed or calculated. It wasn't a guess, it was calculated 44 as the molar mass. That's great. So once you have that skill, then we need to know how to use that in dimensional analysis. So here's what I hope you did. Here's what I hope you did. Carbon, there were 3 of them, so 3 times 12 is 36. That's for the carbon. And hydrogens are 1 apiece, 1 each, and there are 8 of them. You can see it in the molecule here. This is the 3D structure, 8 of those. So total is 44. The label on that, some of you have trouble with the labels. You say, I got a number, I don't know how to label it. The label on molar mass is grams per mole. Grams per mole. And that's a conversion factor. Anything that has the word per in it is a conversion factor. All right, going to the next slide. You get to choose. Well, this is a draw one. So you are supposed to choose A or B. It's not both of them. Only one of the 2 setups makes sense. So pick which one you like and try to cancel the units. Something's got to cancel. If you're doing dimensional analysis, something's got to cancel. And then try to calculate an answer. So I'm asking you to draw that. Okay, so people are choosing, people are canceling, people are trying to fit the number in the box. So there's more than just choose this time. So if all you're doing is circling, then keep going. cancel the units that cancel, and try to get a numerical answer. Good. So we have a lot of things coming in now. It's beautiful. We are reaching consensus. If you remember that very important scientific skill of saying, if we all agree on the answer, then it's probably the right answer. We are reaching consensus. Okay, beautiful. All right, so a few more seconds here, and I will share with you the responses that have been provided. Some of them are a little hard to read, but they look great. Okay, 5, 4, 3, 2, 1. I'm going to lock the screens. I'm going to show responses on Zoom. All right, so you can see that a number of people have chosen B and came up with the answer of 2,156 grams of propane. So that is the correct answer. Yeah, looks like we got very well done on that. Some people did choose A, so we'll go back and say why A is not the right choice for this setup. But well done. If you got 2,156 or 2,160, that's a good sign. Some people will, well, let's just go back and show you how to do it right. So I said something must cancel. So here on my slide, I'm hoping you see moles cancels moles. So need to have the moles on the bottom of the conversion factor for them to cancel out what you started with. That's why A doesn't work. A doesn't work because grams are on the bottom there, and grams can't cancel moles. That just doesn't work. B is the correct choice for the setup. The calculator, you do 49 times 44, because 44 is on the top, so it's multiplication. You can divide by 1 if you want to, but the answer is 2,156. So if you got that, good job. Good job. That's how dimensional analysis works. Okay. I think we're ready to go forward. Next slide has this question. I probably should go back, right? Let me go back first. Yeah. All right, so we now have 2 answers to the original question. The original question was, if you need 108,000 kilojoules, how much propane do you need to burn? We now have 2 answers to that. You could burn 49 moles of propane. You could burn 2,156 grams of propane. Those are both valid answers. One might be more useful to you if you are actually in a real life situation. All right, here we go. Here's now a third way of answering the question, because Americans typically don't measure in grams. How many pounds for you Americans? How many pounds are there in this 2,156 grams? So instead of asking for you for an answer, I'm saying what information is needed. So think about that in general terms. What information is needed to answer this question? Okay, good. I'm getting responses. I'm already up to 10. Okay, some people are not answering the question as intended. You'll kind of see that. Question is, what information is needed? And most people have written some words. Great. Ooh, and it told me who did not respond. That's cool. That's really cool. Great. I've got 20 responses, and I know which 5 didn't. Okay, good. All right, it looks like I'm going to get 20 responses. So I'm going to lock the screens, look at your Zoom, and see what other people said. And it looks like we have consensus here. We need a conversion factor, is what you'd say in dimensional analysis. We need the conversion factor for grams and pounds. And all that is the answer to the question, how many grams are in a pound? How many grams are in a pound? That's what a conversion factor is. All right. Some people looks like they did look it up because it's easily look upable. And that's what you need to do sometimes when you're doing dimensional analysis, is say, I need this information. Let me find it out. All right. So the next slide is asking you to say, well, now that we have that information, I rounded to 454. I rounded it to 454. Now I'm asking you to draw and say, well, that's useful, but how is it used to get to the answer to the question? How many pounds are in this many grams? What does the dimensional analysis look like? Okay, so I'm seeing that people are having trouble fitting in the space there. Yeah, okay. That's for me to live and learn. It's hard for you to fit your answer in the space. Okay, that looks great. That looks great. Okay, so most people are using the conversion factor idea. And when you have a conversion factor, there's something on the top and something on the bottom. Okay, good job. Ooh, Elle writes, oh, Elle's probably using her special writing drawing tablet because hers looks like pro. Okay, thank you, Elle. All right, looks good. Some people, looks like they were able to type it. That's cool. That's cool. You'll be able to see. I'm ready to show responses now. Ready to show responses now. Okay. All right, so take a look at your Zoom screen and see what you think about what people have written. There seems to be consensus when I look at this that it's grams that have to cancel. And so I see a lot of grams canceling out. Though it's not universal. You can see a lot of people didn't know what to do here. So if you're one of them, that's fine. That's great. That's why we're here. We're learning. So let me, I think, show how I would set it up and say why. And hope you can learn from that example. Okay, here we go. So the conversion factor relates the pounds and the grams. And I wrote it with grams on the bottom so that the grams in the beginning would get canceled. Slash grams cancels grams. On the calculator, I multiply by what's on the top, divide by what's on the bottom, and I'm hoping it makes sense to you that this is roughly 5 pounds. If a pound is 450 grams, then this is about 5 times that. So it's about 5 pounds, more accurately 4.7. For those of you who may wonder, where did this silly LB come from? It is the abbreviation for pounds, but where did it come from? Some of you may know Libra is the scales. So since pound is used to weigh things and Libra, the scales are used to weigh things, that's why we have this LB as the abbreviation for a pound from the Latin, the original Latin word. It was actually Libra Pondo, and we kept the pound, but we used the abbreviation of the Libra part. All right, so there's another example of dimensional analysis, and we have only a few more slides left. and that's good because I'm on schedule. All right, let's go to the next slide. This one is not one you get to do anything with, but the original question. It's always good to go back to the original question and say, where am I in this problem solving? Have I got an answer? Have I got the only answer? Let's take a look. So how much propane must be burned to provide 108,000 kilojoules of energy? Well, one answer is 49 moles. That is a quantity of propane. Most people in the world would not understand that. Only chemists really would say, oh, 49 moles. I know exactly what you mean. Whereas these others, more people in the world would understand. If you're European, this makes perfect sense, 2,156 grams. And if you're American, this should make perfect sense, 4.7 pounds of propane. This number here is not a random number. It is the average quantity of electricity that an American uses each day. So if your electricity came from burning propane, about 5 pounds of propane every day would give you electricity. Okay, here's the last problem solving here. All right, here's another question that a lot of people care about. How much does it cost? How much does it cost? So I'm hoping you're reading the prompt with me. How much would it cost to supply this energy by burning propane? So here the question is, what additional information is needed to solve the problem? What do we need to know to figure out the answer? Okay. All right. There's a nice answer. Okay, yeah, so a lot of things are coming in. I'll be able to show you the responses very soon. Some people are realizing that this information is a conversion factor. So things you write in words can be conversion factors. And some people in their responses are using the word per. And whenever you see per, P-E-R, that's a conversion factor. It's relating two different units of measurement. Okay, I'm up to 15 responses. I know which 10 have not responded. A few more seconds. Okay. A few more seconds. And good. Okay, so I got a few more responses by saying, I know who hasn't responded. All right, I'm going to lock screens at this time. Boom. So if you didn't finish, that's okay. But here's what I can show you. So look at your Zoom screen now. And see, this is what information we need to figure out how much does it cost. So you can see the second one here says a conversion factor. And it will relate grams or pounds to dollars. Cost per gram or cost per pound. This is saying the same thing. The cost, conversion factors, cost per pound. Yeah. Okay, good. So this is what we need, and it is a conversion factor whenever it relates to different things. Like in this case, it's dollars and weight. Dollars and weight. Dollars and weight. And that's not as easy to find on Google as the previous one, because it depends who's selling this. Who's selling this? Okay, but here's my next slide. And here's a real life picture. Most households buy propane in containers like this. And you can see the cost is $20. And that gets you 15 pounds. It's not labeled in the picture, but this canister has 15 pounds of propane. So now, with that information, and remember, we already solved for the quantity of propane burned is in the box here on your screen. So go ahead and try to do a dimensional analysis setup. Hope there's enough room for you to do that. Okay, I can see your responses. Thank you. Let's see if we reach consensus on this one. Let's see if we reach consensus. Okay, good. So it looks like it's fairly easy to change your mind. If you did something you didn't like, you can change your mind. Okay, that one's really small. Okay, cool. All right. I have 14 responses. Once again, I can see who's not responding. Okay, so this is our last problem solving of the day. So let's give you a few more seconds and see whether we can learn by looking at the other student responses. Okay, some people have a setup without an answer. If you can, get an answer, because that's a meaningful question. If this is really the amount of electricity you want per day, and burning propane is one way to make that electricity, how much does it cost? How much would it cost? Okay, so it looks like we got some numbers coming in now. Yeah, so a lot of people do have an answer in dollars. Some people have circled it. Some people are not knowing how to get an answer. Okay, that is fine. That's fine. That's why we're doing the responses so I can see them. Okay, I'm going to lock the screens and ask you to look at the Zoom screen. So looks like if we were to say, is there a consensus answer? Yes, there is. It's $6.26 or $6.27. And most people who got an answer got that answer. All right, so if you, let me just take one as an example. This one looks pretty good, huh? All right, so if you look at this student example, it's hard to read because it's probably written with the mouse, but there were pounds in the beginning, and so pounds has to cancel. So this is how you know if you're doing it correctly. If you say, I can't cancel anything, or I'm making pounds cancel dollars, then you did it wrong. You also have to tell the truth. The conversion factor is $20 for 15 pounds. So this is the truth, which makes it so that this setup is valid. Pounds will cancel. $20 for 15 pounds. You multiply by what's on top. So it's 4.7 times 20. Divide by 15 on the bottom, and you get $6.26. So that is a good example for you to see. Maybe this is a good example too. So this one, the red one here, is great, except it should have the slashes showing, yeah, pounds cancel pounds. That's how you know it's correct. Pounds cancels pounds. All right, so if you are not there yet, if you are saying, I still don't know which number to put where, then Wednesday will be the day you can get more individualized attention. So Wednesday, instead of having a class of 25, I'm hoping to have classes of 4 or 5 students. And we can have a dialogue back and forth. And I'm going to recruit some ACR students to help be teachers because some of you still need more individualized help. All right, I am over time, so I'm going to skip this slide, but I'm going to go to this slide. So please put some feedback on the screen there. You just drag your dot, and that'll help me know whether this was a good approach or not. Okay, some dots are moving. Some dots are moving. Okay, I'm locking screens in 4, 3, 2, 1 locked. All right, so here's the responses for that. So it looks like it was a positive experience for most of you. So thank you for participating. I learned a lot. I like the interaction part. I would like it even better if we could talk to each other. So that's what Wednesday is for. That's what Wednesday is for, that we can talk to each other. All right, thank you for coming today. If you do want to look back at this lesson, it has been recorded, so you can access it later on. If you forgot, how did he do that? Or how did my classmates do that? It'll be on YouTube. All right, thank you very much. And hope some of you are going to the poets that are reading at noon. Bye-bye for now.
Thank you, Mr. Soga.
Thank you.